Hello, welcome back. So we looked at a couple of things. We looked at lines that go on forever, essentially because they're functions. And so today we will look at segments, which are basically just lines that have a start and an end point. Right, so let's start off with distance between 2 points. Distance between 2 points. Alright, so let me draw a graph first. Alright, so here I have drawn a horizontal line, and we can see that it's a horizontal line because the y value is constantly at the same thing, it's at 1. Right, so it's a horizontal line, and so if I ask you what is the distance between these 2 points, what is the length of this line? Right, so we see that only x is changing, and x went from 2 to 5. So the change in x is 2 minus 5, which is minus 3. Right, and since we are talking about distance, what I will do is I will mod this, because distance is a scalar quantity, it cannot be negative. Alright, so the change in x over here is 3, and so we can conclude that this length is 3 units, right, because that's all that's happening. Similarly, if I draw a line over here, let's say something like this, which is 1 comma 1 to 1 2 3 4 5 comma 1, we see that now this is a vertical line because the x component is not changing, right, and the change in y component here is 4. So the change in y is 4, and so we can see that this line will be 4 units. Alright, now let's say instead of having convenient points, let me take some random point like this and this diagonal, and I ask to find the distance between these 2 points. So this is -1 comma -1, this is 1 comma -1, and 5 comma -3. Alright, so if I just look at these 2 points A and B, I can see that y went from -1 to -3. So the change in y would be 2. Change in y is equal to 2. Right, the change just means the difference between them, so you can subtract those two together, and I'm taking the positive value for the purposes of distance. Alright, so the change in y is 2, and the change in x is 4, because 5 minus 1 is 4. And so we get that between this diagonal it makes a triangle where this side is length 2, this side is length 4, and so what we can do is, this is what we want, d, we can apply the Pythagoras theorem that d squared will be 2 squared plus 4 squared, and so d will be square root of 4 plus 14. Alright, and if we generalize this between any 2 points, x1, y1, x2, y2, the distance between those 2 points will be the difference in x, x1 minus x2 squared, plus the difference in y, y2 minus y1 squared, and then that under root. Right, so this is the distance formula. Alright, so now let's talk about midpoints. Number 2, midpoints. Alright, so as the name suggests, midpoint is the middle point between any 2 points. So if we look at these 2 points A and B, right, let me connect them by a line. So the midpoint will be some point such that it is equidistant from these 2 points. It is the middle point. So what you do to find the midpoint is simply take the averages of both x and y components, because averaging is really just taking the middle value. So we have 1 comma 2 and we have 3 comma 6. This is A, this is B. The midpoint, I will just write mid of A and B, will be 1 plus 3 divided by 2. That's how you take average. 2 plus 6 over 2, and so we get 2 comma 4. Right, so this point will be 2 comma 4. It will be the midpoint of it. Right, the perks of being the midpoint is that the distance from here to here is equal to the distance from here to here. So since we are on the note of midpoints, let's talk about perpendicular bisectors. So we have already discussed how perpendicular lines are basically two lines that make a 90 degree with each other, and they have this formula that m1 multiplied by m2 will be -1. And so I have a line here, well actually I have a segment, but for this line I can create a perpendicular bisector, which is another line which makes 90 degree and it passes through the midpoint of it, right? And so in order to make equation of any line, I need a point and a gradient. The gradient, let's say m of AB, will be y2 minus y1 over x2 minus x1. It turns out to be 4 over 2, which is 2. So we know that the m of normal, which is the perpendicular line, will be -1 over 2. Right, so we have the gradient, and we know that one of the points will be 2 comma 4, so we can substitute that. Say 4 equals -1 over 2 multiplied by 2 plus c would turn out to be 4 plus 1, which is 5. So we get our equation, it is -1 over 2x plus 5. Now one more thing to notice is that this point A, okay, so let's call this midpoint point M, let's say. So one thing to notice is that B is a reflection of A onto L1. So if I take this point and I reflect onto this line of L1, I will get this point B. It is like mirror image. Alright, so let's say you have this point A and you have this line L1, where you know what the coordinate of foot of perpendicular is, and you want to find the coordinate of this when you will reflect it. So if you go ahead in the same distance from here, this is some point C, and you want to calculate this coordinate C. So one way you could do this is first argue that from A to B, the change in x is, well, 3 minus 6, which will be -3, and the change in y is 1 minus 4, which is also -3. Right, what I'm doing is B minus A, because we're going from A to B. And so what you will do is argue that the change from A to B will be the same as the change from B to A, right? And we know B is 3 comma 1, so we will subtract 3 because of the change in x, subtract 3 because of the change in y, we get 0 comma -2, and that is our coordinate. Right, and another way would be to treat B as a midpoint. So B is the midpoint of A and C. Right, let's say C is some x comma y. So 6 plus x over 2, 4 plus y over 2 should equal 3 comma 1. Right, 6 plus x over 2 should equal 3, 4 plus y over 2 should equal 1. X will turn out to be 0, y will turn out to be -2, and we get the same answer back. Alright, so one last thing that we will look at is the area of any shape in the Cartesian plane. So let's say you have any shape that is connected by lines, something like this, and you have the coordinates of all the vertices. Right, there's a certain way of finding the area of the shape. So let me draw a proper graph. So let's say you want to find the area of this triangle, right? And if you have any x1, y1, x2, y2, all the way to some xn, yn, the way you do it is the following: half x1, y1, x2, y2, write all of those up to xn, yn, and then again completing the loop to x1, y1. And then what you do is, this by the way is a modulus sign indicating that it must be positive. What you do is you multiply these, you multiply diagonally, you add them all up, and then you multiply this diagonally, you add them all up, and you find the difference between them. Right, so if you look at this example, we have the following coordinates: 2 comma 1, 1 comma 3, and 4 comma 4. So if I arrange this, it would be 2 1 1 3 4 4, and then again 2 1. Alright, and actually it doesn't matter whether you do this diagonal minus this diagonal or the other way, because of the modulus. So 1 times 1, I'm going to multiply this diagonal first. So 1 times 1 is 1, 3 times 4 is 12, 4 times 2 is 8, and then we have minus 2 times 3 is 6, 4 times 1 is 4, 1 times 4 is again 4. Close the modulus. This would turn out to be 21 minus 14, and so we get 7, and the answer would be 7 over 2 units squared. Right, of course you could have done this the long way by finding some of the lengths, some of the angles, but this is an easy direct way to do this. All right, and that's it for today.